So having said that, next off we look at the classification of lipids based on their structure. Lipids can be classified based on their structure, and then they can also be classified based on their um, they can be classified based on their structure. They can also be classified um, based on their components as well. They can also be classified based on their electrophoretic mobility, and they can be also classified based on their apolipoprotein content. But we'll start by looking at classification of lipids based on their structure. Classification of lipids based on their structure. So now we begin. Lipids can be broadly classified based on their structure into fatty acids. They can be classified into fatty acids. They can be classified into triglycerides. We're still looking at based on their structure. They can be classified into phospholipids, and then they can also be classified into sterols. So we'll look at them one after the other. Let's begin with the fatty acids. Now, the fatty acids are simple lipids, um, and they make up the building block for more complex lipids. So when you are talking about complex lipids, fatty acids are the basic components that are built together to form the complex lipids. Now they are carboxylic acid with a long chain hydrocarbon. Fatty acids are simply carboxylic acids with a long chain hydrocarbon. Now, describing their structure, you have a carboxylic group at one end of the fatty acid. You have a methyl group at the other end of the fatty acids, and both the carboxylic group and the methyl group are connected by a hydrocarbon chain. I'll go over that again. We said fatty acids, they are carboxylic acids with long chain hydrocarbons. So that means at one end of the fatty acid, you have the carboxylic group, and then at the other end, the other extreme of the fatty acid chain, you have the methyl group. So both the carboxylic group and the methyl group are connected by a hydrocarbon chain. So we'll look at these fatty acids. Now, fatty acids can be classified into saturated fatty acids and unsaturated fatty acids. Now, the saturated fatty acids are the fatty acids that have no double bond in between the carbon on the hydrocarbon chain. So that means that the chain is a straight and flexible chain, and then because it is straight and flexible without any double bond on across the hydrocarbon chain, they can easily be folded. They can easily fold and they can easily be tightly packed together. Now, example of saturated fatty acid include palmitic acid. You have the stearic acid, the palmitic acid, and the stearic acid, and they are usually solid at room temperature. They are solid at room temperature. I'm sure you have seen some of these saturated fatty acids. For example, at one time or the other, you have seen groundnut oil, so to speak, that people sell. They arrange them, they sell them in bottles, and then you observe that once the weather is cold, or maybe there's rain, or during very cold weather, you see that these oil begin to cake, and then they begin to change color into off-white color, and they are thick. Those ones are saturated fatty acids. They are saturated, so at room temperature, normally they solidify. Then the other type of fatty acid is the unsaturated fatty acids. Now, these unsaturated fatty acids usually have one or more double bonds along their hydrocarbon chains. One or more double bonds along their hydrocarbon chains. For example, the monounsaturated fatty acids contain one single double bond. It contains one single double bond along its hydrocarbon chain. And an example of this one is the oleic acid. Oleic acid, and which is the olive oil. That's why you see that olive oil has been pronounced as one of the best oils to use to cook our daily meals. The best oil to use to cook our daily meals. They are unsaturated and they are liquid even in cool temperature. They remain liquid even in cool temperature. So at room temperature, they are liquid. The likelihood that they will form flakes when you consume them is very slim. That's why olive oil is very expensive. Now, our other oils that we eat, our vegetable oils and all the other oils that we use to make our meals and eat, those ones are still unsaturated fatty acids, but they are polyunsaturated fatty acids. Now, if you want to look at the market price of those ones, they are cheaper compared to the olive oil. So the amount you use to buy 5 liters of the other oils, the other polyunsaturated fatty acids, you can use it to buy just 1 liter of an original olive oil. So that's for monounsaturated fatty acids. So the polyunsaturated fatty acids, they are fatty acids that contain multiple double bonds, at least 2 double bonds. An example of it is linoleic acid, that is mainly found in our vegetable oils that we consume. So they have at least two double bonds. So they have two or more double bonds. So these ones are polyunsaturated fatty acids, while the monounsaturated fatty acid, which is olive oil, has a single double bond. Also, these unsaturated fatty acids can be either in the cis form or in the trans form. The cis form or in the trans form. Now, in the cis form is the one that the hydrogen that is attached to the double bond. The hydrogen that is attached to the double bond is in on one spot. So the cis unsaturated fatty acids, there are hydrogen ions attached to the carbon atom that is carrying the double bond is on the same side. Either the two of them are to the left, on the left side, or both of them are on the right side. But the trans fat, the hydrogen atom attached to the double bonds, to the carbon that is at the two carbons that is at the double bond, either one of the hydrogen atom is to the left and the other one is to the right, or one is to the right and the other one is to the left. Now that is a trans unsaturated fatty acid. Now the cis unsaturated fatty acid are the naturally occurring unsaturated fatty acids, while the trans unsaturated fatty acids are the artificial unsaturated fatty acids. So that's why you see that cis unsaturated fatty acids that are naturally occurring usually have the double bond in the cis configuration, which introduces a kink to the chain. So that one at the cis fat with the hydrogen atom on one side will form a kink, and this kink prevents the packing of the liquids, and so it prevents them from solidifying. Unlike the trans fats that have these are from they have the straight chain. The chains are they are they can be easily packed, and then when they are packed, they behave more like saturated fatty acids at some point. they can become solidified. So the best and most healthy unsaturated fatty acids are the cis unsaturated fatty acids. Now remember that the trans unsaturated fatty acids are usually cis can be converted to trans in such a in the sense that when you have used maybe a particular oil to fry and fry and fry and fry and fry, before you know it, there's a transformation from and it becomes a trans fat. So reusing a particular oil over and over again is also detrimental to the health.